Thank you. I apologize about the hiccup there. I was in the zone. Um, this is probably going to be one of the more unorthodox talks that you'll have at the conference, and essentially it's a story of kind of how a group of really unlikely people ended up becoming obsessed about the AWS infrastructure. And I'm kind of walk you through a little bit. I would ask patience just a little bit because there's some admittedly non-technical and very non-security context that I think helps sort of frame this and sort of explain our mindset and kind of what our approach was and what we've discovered. So I should first start out saying I have no financial interest or contacts or anything with Amazon other than a friend or two, but nearly everything that I'm going to be presenting is out there on the web. It's public information. Also, I'm not sure if it's on the side, but it's sort of a standard thing. I'm speaking as a security researcher and not as a sort of official person for my company. So I don't know if you read the bio. It's probably not the typical bio of folks that come up here. So this is a little bit about me. Most of my career in the last 15 years has been spent in clinical research, clinical trials for drugs specifically. I work at the intersection of genomics, medicine, pharmacology, and complex information systems. So this is for the ninjas to snark up the comments about complexity. Okay. So drug industry. It's like a badge of shame or something. I hope that's not true. I don't think it's true. So here's some things that my group is working on. We're effectively the nonprofit arm for the National Institutes of Health, which is sort of the major biomedical government funding agency in the US. We also have pretty close ties to the World Health Organization and the UN. We do some work with foundations like the Bill and Melinda Gates and the MacArthur Foundation. But we are a commercial company, but probably, as it says, 98, 95% of our work is government grants. So we're working on some big, complicated problems. Pandemic influenza, bird, swine flu, H1N1, antibiotic-resistant tuberculosis, and so on. And unlike, I think, the perception by sort of large pharmaceutical companies, and I should make the distinction, we are clinical research operations, clinical research execution. We don't develop drugs. We don't have chemists and monster supercomputers and things. By the way, I don't know if you all are aware of this, but just in terms of compute power, there's the top 500 list, the SC. I discovered about a year or two ago that I think 4 or 5 should be on that list, but they're not because they're privately held by pharma. So Pfizer, for example, has one of the biggest supercomputers in the world, and they don't. It's not like they need credit, but it's almost like the hidden web in a sense because it's just because of the competitive nature of drug development. So much is a person can work on a project for 7 years and never be able to talk about it, and can't go to conferences and can't explain some of the really cool techniques and so forth that they're doing. So it's in that context. So I mentioned complex systems. So what does that mean exactly? Well, in my vernacular. This group's been around for about 30 years. Our team right now is growing to support the Operations Center for the largest clinical trial research network in the world. So a lot of people work in, developing nations. This isn't new. What's complicated is the scale and the speed of our execution team. And I'd say there's been a pretty good insight 6 years ago or so that said, it's not enough to have great epidemiologists. It's not enough to have good pharmacologists and chemists and this sort of thing. You can have the best potential compound or vaccine or whatever. If you don't have solid technology, these projects die. So I don't know if you all have heard this statistic. There are a few groups that sort of debate the finer point, but it's estimated $700 million to about $1.2 billion to bring any new compound to market. So that's from the discovery point, the computer modeling, all the way to being able to be used in patient groups. And it's really insidious in the developing world because there's a lot of what's called orphan diseases, which may have millions of people suffering, but they don't, there's no profit motive because effectively what's going to happen is kind of generic drugs or things that are not, they're completely out of alignment to sort of the North American and the Western Europe business model. So that burden has fallen on a lot of government agencies. And despite sort of, I think, the conventional wisdom, places like NIH, like the National Health Service, like Health Canada, and I forget the name exactly, but the equivalent bodies in Japan, it's not that these large pharmas have thousands of scientists and they're working away in labs and they're working on cancer and compounds and things like this. It's much more complicated. There is such a close tie between foundations, academia, and the private sector, particularly these days, because I think in the last 3 years, there were 12 to maybe 14 compounds that went off trademark protection. So, and some of the other ones are coming up. So this is, Viagra, the ulcer medications, pain medications, psychiatric medications, the high blood pressure medications. When those come off, big pharma, and by that I mean 10, 20, $30 billion companies, they really have been scrambling in the last few years to find new compounds for their business model. We're obviously not at that scale, but the point is, so in that context, they're not looking at a lot of these sorts of contexts. They're not interested. A lot of sort of larger pharmas are not interested in in things for basically government health efforts. So what did I mean by phase 1 to phase 4? And just as I said, kind of indulge me a little bit if you would. So you guys will walk out of here, you'll be certified MDs by the time I'm done. So clinical drug development 101, phase 0 or preclinical, that's where we have an idea. There's maybe some big data that's been crunched on the genomic side. Lots of literature review, lots of understanding of complex multidisciplinary areas. Lots and lots of computer models because that's cheap. In vitro studies, that's when you first start looking at, is the compound that you're working on toxic, is it beneficial to the living tissue, and then in vivo studies. That's, that's where it goes in animal. So phase 1 through 4, in vivo is where it begins to be prepared for animal studies prior to human research. So phase 1 to 4, clinical. So you do the same thing, but you do it with people, and there's lots more rules. So, too lazy, didn't read. Here's how clinical research works. A thought, maybe by an evil genius, computer model, tissue, mouse, monkey, college student. That's how clinical research works. Eventually, when we can figure out what the maximum tolerated dose is, whether the compound's toxicity and so forth, and if it's actually safe, then we move into phase 2 with actual patient groups, be it Alzheimer's, be it cancer compound or something like that. And then, when we show some evidence there, these are, as you can imagine, 10-year processes. Phase 3 are large-scale, multi-center trials. And multi-center, I mean, Boston University, UCLA, major institutions around the world. So, you're sitting there going, and this matters to me because, well, drug development and clinical trials are highly regulated. So, when we implement the systems I'm talking about, it's a formal process. It's not quite to the level of DOD, but think about it. If you're, and it's not just drugs too, by the way, I should say devices. If you're developing a new pacemaker, the way that you build software for that, you're not doing rapid development. It's not like it compiled and so you're shipping it, right? I mean, you really don't want to do, lean development for life-critical device development. And also, if you're looking at really sick groups with drugs that in some cases have never been given to a human ever, it's really critical that if you've got name-value attributes, that they are absolutely consistent, that they're in sync, that these systems are completely robust and transactional. In addition to all that, there are all kinds of health authority rules and things. I like Andy Ellis's idea about the security poverty line, and this is a great example. I never really thought of it this way before, but there's sort of a subtle security poverty line in this world, because in academia, where it's not profit-driven, you have potentially great ideas and innovations coming, but often a really deep naivete of what the regulatory burden is to actually get it from the lab, from the bench, to the bedside, to the patient groups. And that permeates so many levels, but one of the ways we see it is on the security side, is on the infrastructure side, is on the sort of repeatability side. And increasingly, people are talking about, and health authorities are framing this as risk-based. So, in those crime movies when, somebody's been murdered and they collect the evidence of the crime scene, and there's always this conversation about the chain of custody, right? So somebody picks up a sample and, well, Officer Bigelow gave it to, this guy, and this guy gave it to that guy. You have to be able to say, from the time that the data were picked up or ingressed, where it was every step of the way. Because remember, these are 10-year programs. So, it's one thing to think about drivers and support and vendors and things a couple years out. Some of these things are 10 or 12 years long, the systems that are in place. So, this is for one of my systems. One. For a relatively small part of the company, this is the documentation burden. Requirements, testing plans, risk mitigation plans, deployment, security training, the whole thing. That's for one system. Ow. But it's also lazy because I think when people who have a strong engineering or software background or security background sort of start to get into this world, we think, well, it can't be that much different than, say, Sarbanes-Oxley or in the financial world where, those are regulated too. But it does. It's crucially different because of this. We're dealing with life and death issues. If you're interested, there's a great, a fascinating read. Happened about 3 years ago in, it was Oxbridge, but somewhere in the UK. There was a clinical trial for, it was basically kind of a pain relief compound, as I recall. Had beautiful computer models, great animal testing, all the tissue results looked fantastic. And when they brought in basically these young college student age kids, healthy people, to do this trial, they made a mistake, which was to say, I think there were like 11 people in the trial, all 11 got the dose at the same time. It's a kind of a hideous moniker or whatever, but if you Google Elephant Man or Elephant Man syndrome or something like that with a clinical trial, you can read this story. But basically, there was what's called a cytokine storm. The body did not like that drug, and there was permanent, massive, hideously painful, effects immediately. So this is the sort of thing. If Memcache dies, it's not like we're missing a comment. If Memcache dies, the database is eventually consistent. We have to tie attributes. Time is critical. So many different data points are being collected. It's just a different thing. And it's not different just because there's a lot of paperwork and you have to understand the regulatory side. It's different because of that. So maybe a little better illustration why science is hard. So you guys have all seen this little cartoon, on the movies or whatever, the heartbeat. There are people who spend their entire careers, I'm not kidding, their entire careers focused on that part of the heartbeat. EKGs or ECGs have been around for, 100 years or so in more or less crude forms. It was discovered about mid-'80s, I believe. There was a healthy young woman, I think 36 or so. She presented at a suburban hospital just outside of DC with severe chest pains and things. Great shape, no history of any of this sort of thing. Thanks. And had a pattern on her heart rate that people hadn't seen, that the physicians since medical school. It's like one of these rare, weird things. It's called Torsades-Dupont syndrome. And what it is a very subtle, did you catch that? Very subtle change in the heartbeat. So if you lay those on top of each other, it's still kind of hard. If I lay them directly on, then you can see it. So this little push out, this little delay in that bump on the waveform, as little as 5 milliseconds, is enough to kill a $300 million compound dead for the government to go, no, it's too risky. It's a single complex blown up. And so, and by the way, if you've had one of these yourself, you may have had one or two electrodes or stickers. In clinical research, we use 12, or we We use 8, but we derive 12. So let's do some quick math. 1,000 hertz, 12 signals, 24 hours a day, maybe 7 days per subject, multiple conditions across several months. This gets into a lot of data really quickly. And it's an interesting computational problem, but it also is a safety issue. So, in other words, it's not just a paperwork burden. These systems aren't just databases, and the web apps are getting increasingly sophisticated. It's not obvious on those screenshots probably, but we have a pure HTML5 vector measurement system where literally pixel by pixel we're measuring the voltage and the time on those waveforms. So, the way you think about that, the way you design it, the way you harden those systems, it's just a different mentality from an awful lot of development that you and I may be used to working with. And as we go from animal models to human trials, those regulatory obligations become so much more complex. And rapid development is just not so much. So this is actually to where we are. So what does this have to do with security and technology more generally? The cloud is having a major disruption on this at multiple points, at multiple levels. I'll try to minimize any of the stupid buzzwords and things, but the software as a service and whatever you want to call it, it's evolved into, have really changed the dynamic in huge ways. I like to say beware of the tortoise. So there's good turtles and bad turtles, and you guys have seen these. So there's the institutional sloths, these people that are just deadwood, that have a pulse and they breathe, and somehow they've stayed in their organizations, and they love to say no, or we can't do that, or we've never done it that way. Bad. There's a variant of that in IT, which is sort of the big iron IT. You want a system? All right, great. Well, let's call 3 meetings, sit down, put out 5, competitive bids to Dell and HP and all this, and then we'll have 15 people sitting around the table, and then signatures upon signatures, and then maybe sometime in 2 months you'll get your stuff. Yeah. Then there's the FUD. Then there's the people who have no clue, but they're just vaguely nervous about stuff. We can't put anything sensitive on the cloud. We don't know where it is. As if in a large organization, people really understand, unless they care and they're honest, and there are those. But there's an awful lot of product managers that have no idea where the data are. They have no idea where the infrastructure is, no idea how the replication works, the backup, the disaster recovery, all that stuff. And so it's an easy tactic, and we've seen it before. But on the other side, so what's the appeal? We've got the rapid provision. We can do this on different scales. The enlightened people are those in quality or in compliance who maybe they're not technical, but they're open-minded and they're willing to engage. Okay, configuration versus customization. This is the notion that if you kind of mass customization, if you develop and spend an enormous amount of time to kind of validate one system and put policies around that and controls around that, if you can kind of, not patent, but if you can kind of get the recipe for the stamp, of your system going down, sort of like on a conveyor belt, if you can qualify that process rather than each individual system, or at least make each individual system's sort of, release to deployment dramatically shorter by that, you win the game. And the pre-qualification, as I say, is the nirvana. So here's the promise of AWS that we looked at early on. The scale, you'll see this in just a second, but just in terms of the sheer server infrastructure and IP range and the peering. When we started looking around, part of the thing is we had to understand our own systems and sort of, all these VMs we popped up in our own shop, and other colleagues too. And how many times does this happen? You've got boxes of essays are like, I've been busting my hump to make sure this thing's up, it's patched, it's fully great, but it's behind the VPN or something. And they go to look, and nobody's actually logged into it for 2 months. You take 2 or 3 of those on a larger scale, and it's killer. It's absolutely killer. And it also, in my opinion, it's evidence that there's this disengagement. This where DevOps is, in a lot of use these days. But there is something about that partnership that I really like. And this is sort of an anti-pattern to that when you see that sort of thing. Because it means nobody was owning it, nobody was looking at it. And just general pain reduction, and also the cost. 0 procurement headaches, though. This is one where I think if you're working with a 4 or 5 person shop or maybe 10 or 12, maybe this is not, this is a non-issue. You get to 100, 200 people in a company or organization, much less the Fortune 50, it's crippling. It's the opportunity cost, in my opinion, that's the killer feature. So maybe I'm already saying things that are sort of obvious to some of you, although, I don't know, maybe some of you are thinking that, you'd never, ever touch your systems, in someone else's hands. But I do want to look at this analysis because this is what happens. I can't tell you how many times I've had conversations with CTOs or, heads of IT groups who had the opportunity to sort of, think more progressively long term, and we start calculating, okay, well, a Western Digital hard drive costs this much, and my Dell 2920, 2U server costs this much. Well, look how much it would cost after a few months on EC2. It's like, no, you're missing the point. Because I'm not even going to try to guess what we're paying for electricity and the pagers and the guys 24 hours a day and all that stuff. And then there's this whole private cloud thing, which we could spend an enormous amount of time. I will say, if you have the unfortunate position of having to deal with quasi-clueful managers that know just enough but to get in trouble, there's a fantastic report called Cloudscape, a group called 451. You can get this white paper for free. Truly, no exaggeration. This, to me, was one of the best kind of neutral, industry-wide looks at this whole thing. They went to the most small mom and pop, in rural areas in the States, in Europe, all the way to Amazon, and did really detailed analysis of, kind of what the features were, what the comparators were, who the players were, and that sort of thing. And basically, one of the things they came out with was said in the cloud space, there's like Coke and Pepsi and Amazon's Coke, and there is no Pepsi. But let's say you do want to do this. Do you really want to fend off a large-scale DDoS? Can you? And if you do, how much of your time are you spending on that? This may not be as a familiar service for people here, but Iron Mountain is this well-established company. It's sort of, it's like the sort of, top of the line for document management, and they literally have mountain, in the base of mountains in West Virginia, storage areas and things. Well, at some point a few years ago, they decided they were going to open up file, a pay-as-you-go cloud storage service. It didn't quite last. And you guys have seen this, I'm sure. EMC still, trying to get in this and figure out their strategy. I would not want to have had that conversation with my boss after a year and a half, build up to their products. So, back to AWS. Again, none of this is things that you couldn't find on your own. It just took us about a year and a half to do it. Not this. This is fairly easy. I think people are generally aware about Werner Vogels. He's a really brilliant, thoughtful guy. But I think a lot of people may not know that he came from academia. He had a really interesting, influential series of research papers on the GossipNet protocol. And if you have some time, it's worth a look because it's good stuff. James Hamilton, if you really want to get in the underbelly of AWS, read this guy's blog because he's no BS, he's honest, and he's probably one of the most transparent people I've seen. On the other hand, he is a VP, so there's a little bit of salesmanship, and you see a little bit of this with the, some of the press reports. But in terms of real nuggets, two places that serve the best sources of information for us. One was the SEC filings, the Security and Exchange Commission filings, and the other is Hamilton's blog. Now, I should just say this right out. AWS has a non-disclosure agreement, and if you're a customer of theirs, you can sign this, and they'll give you access to their auditor findings, whether that's in the SAE 16 space or the ISO, that sort of thing. They're not nearly as transparent as they should be, and I think they're kind of struggling with it because I think the instinct is to sort of say as little as possible, hold things tight, and then on a need-to-know basis, for auditors or regulatory authorities, then sort of let things out. But that's a problem because there's some fundamental things that I can't even have the conversation. If I don't know where my data are in the U.S. or in Ireland, we're not having the conversation. Canada the same way. if we don't have reasonably presentable, documented practices, technologies, and people training and so forth to show the controls, it's just not going to happen. So this sort of vague stuff about the availability zones, and well, they're not, they're kind of like a data center, except they're not really. I don't know if you guys have seen this. One of the great quotes I heard was, a data center can be an availability zone, but as long as the parking lots don't connect. I was like, just where are your centers? I mean, like where is this? Where's the pipe? We'll come back to that in a second. But in terms of growth, this is phenomenal if you guys haven't followed this. They added 22,500 employees in the last year, and most of that was in web services. I mean, that's staggering growth. This quote on the second one by Werner Vogels blows me away. Each day, AWS adds the equivalent server capacity to power Amazon when it was a global $2 billion enterprise in 2000. Every day. Wow. I've got some links there. This is their route advertising about 800,000 IPv4 addresses. I'm not really clear what their strategy is on 6. Their virtual private cloud really underestimates that number. So, there's here it is. Li Huan, I have a link here. He estimates worldwide about 500,000 physical servers through Amazon. I think that's fairly low, actually, because the VPCs obviously have, private subnets that aren't, not advertising outside. Okay, so, and then if you want, the links are there, but I put a few just to give you an example. Running down to the subnets where they are by region. It's a lot of capacity. The other thing that was kind of funny too, when I first started looking at this, we had to make a decision, which was, do we go to legal and get a sort of a binding non-disclosure, cross our fingers and hope that it's got the level of detail we need to convince our auditors and our sponsors, because they're tough. And in some ways, our commercial and government sponsors are tougher than the government regulators, because a lot of these things are guidances. They're not hard and fast rules, which frankly is it should be. But so as we start digging around, it's amazing where you can find information. They got busted in their Virginia office for, what was it, pollution control or something, and they got written up for like a $600 fine. Anyway, it's a court document. So in there, they have all kinds of information about their backup generators and what's the model and who's responsible here and who's responsible in Seattle, and there's a little bit of puzzle of this sort of putting together. The capacities they've got, the number of staff and so forth. The other thing too is we spend a lot of time looking at the job ads. They're a wealth of information actually, because you can sort of find out about where particular groups are where they're based, and kind of, they even hint sometimes a month or two in advance, and I've got half a dozen examples of this, if anyone's interested, for new products coming out. Oops, let me just do this. So this acronym SOUP, this was probably the biggest reason why we even went down this road at all. If you're not clear, or if you've not heard the story, it's under the Obama administration about 2 years ago, there's an initiative called the FedRAMP. FedRAMP says you will cut 10 to 20% of your IT costs by putting in a public cloud or cloud. And so there was, you may have seen some of the stories back and forth about Google and Microsoft and Amazon grumbling and throwing barbs back and forth about who really had cloud and who was really compliant and so forth. Those aren't so interesting to me, but what is interesting is the number of agencies, of high-level agencies that have moved critical infrastructure there. This is energy, this is the NSA, FBI, the Department of Justice, major infrastructure. There was a conference in November in DC, and then there's a link later where Vogels and his team presented their kind of compliance that they've gone through. This has been a multi-year process. And two, just as a quick aside, if any of you have to deal with that, there is some misinformation out there, which is Amazon has a very special set of data centers called GovCloud or something like that. You have to be a member of the U.S., you have to be somehow related to the U.S. federal government. And really, the only difference is they put stricter procedures in for hiring. So foreign hired people, there's something to do with the ITAR regulations and so forth. But anyway, there's some notion that in order to be what's called FISMA compliant, which is in the federal space sort of levels of control that one must reach for certain contracts, and ISO and these sort of things, in order to meet those, you have to be in that special, really expensive and really walled garden. It's not true. I've got dozens of examples where their compliance is absolutely consistent across all the groups. And then part 11, that's the part in the healthcare spectrum. And so that's what interests us the most. So when we have auditors come to us, sometimes as much as once a month, they say, where are my data? How'd you back it up? Let me see it. Let me see your backups. Let me see your people's training. If somebody says they went to University of Chicago or whatever, University of Texas, I want to see their diploma. If we have physicians on staff, they want to see their board certifications. They want to see the diplomas. I mean, they really do that. And so you don't want to trifle with these people and sort of wing it. And by the same token, we're what's the phrase? Sort of critical consumers or skeptical consumers of claims. It's sort of like, okay, well that's interesting. Now let's see more detail. So this was awesome. Have you guys ever, just a show of hands, Digital Realty Trust? How many know that name? Yeah. They're one of the most important companies on earth for technology. This is such a great thing. These guys go in and do really boring things. They go in the US, in Asia, in Ireland, and they get the big burly guys with the concrete foundations and put the slabs up and figure out how the plumbing works, literally the plumbing, and the electric lines and all the local permits and zones and dealing with the citizen action boards and making sure they don't have any impact environmentally and this sort of thing. And they do a lot of the just building infrastructure. Their biggest clients are Amazon, Google, and Apple. And they're a multi-billion-dollar company. So they bring up these data centers basically to spec. So you can say, I want so many megawatts. I want 15 fiber lines coming in east side of the building, 15 on the west side. If this one's cut with a backhoe, we're still good. I want 3 different substations, one on site, one a little further out, and a third one somewhere else. They can do that. They literally partner with local power utilities to add more electrical grid. I mean, that's a highly specialized thing. But they also are a publicly traded company, which means everything they do and their biggest clients, it's all on the record. So, whenever there's Northern Oregon or Northern California, some of the new data centers that were open, 2 years earlier, if you look at the SEC filings, they talk about, here are our top clients, here are their addresses, here's the properties that we put up for the bank for, credit lines and so forth. And it'll say in there, blah, 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 Devonshire Place, Ashburn, Virginia, DC1, blah, 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 LA West, Westwood West or something like that, which is the, Amazon West. Awesome, if you're an analyst. So they have some of these. I'm not sure if people are familiar with kind of the distinction between their edge network and the core compute. It seems like every week they've got additional capacity for their content distribution network. And those are fairly, well, at least to the city in the world, they're transparent. Beyond that, you've got to do a little bit more digging. Direct Connect, I'm not sure if folks are familiar with this or not. This was actually really clever. This was a technology developed in the Virginia office. By the way, that's also really hard to find out. Phone numbers and addresses of their offices. Right? I mean, the big one in Seattle, that's easy. But, where do the developers sit? Where do those things get built? Well, it kind of clusters by product, actually. It's a little bit of an aside, but there's a great sort of, I don't know if it's a rant or, I'm not sure exactly how you'd refer to it, but there was a guy that he was a senior engineer at Amazon in, I think, 6 years or so, and he went over to Google, I think, 3 years ago. He wrote an internal memo to what he thought was his friends on Google Circles inside, but in fact, he got the permissions wrong and it was public. And so there was just some really candid stuff about dealing with Bezos, dealing with how the product groups work, how the mindset is, just the grind, and the kind of chaos of that sort of corporate culture. It's a fascinating read. But anyway, Amazon's incredibly flat. I didn't go to any pains to do an org chart because it wouldn't matter. People can argue all the way up to Bezos. I mean, still, if you think you've got an idea, they can go that high. It's a painful process, as I've understood, because, as somebody put it, Jeff Bezos' job is pretty much to wake up in the morning, dress himself, and then read presentations, and he does that really well, at least the last part. So the Direct Connect, anyway, that's one of their products that was developed in the Virginia group, where you can, literally, if you've got co-location at Equinix, which, by the way, that's their other major, it's not so secret to people in the networking world. Equinix is a huge presence, but I think a lot of people didn't realize the really, really tight connection between Equinix and Amazon. One of the reasons that Amazon was able to bring up Singapore, for example, so quickly is because they're directly tied into the MPLS fiber, submarine fiber from Equinix. Well, when competitors are doing 200 millisecond latencies and you can do it in 6, that's pretty compelling. But it's a weird relationship because Equinix has sort of toyed a little bit with cloud kind of things, but they've not done so well. What they do really well is keep the lights on, keep the 90 plus different ISPs going, and keep those pipes lit up all the time. And they're growing like mad as well. Anyway, if you're co-located in one of these data centers, you plug in and you've got instant on-ramp to their backbone. So silent construction part, we talked about that. Yeah. So the physical controls, process and technical. If this is something, if you're in an industry that is regulated, or if you just really want to care and you really want to understand how, to what extent they've gone to put their systems in place and maintain order, there's actually 3 or 4 white papers where they lay out in fairly decent detail, actually, their boarding process, their employee process, fairly decent details about the VM separations and kind of both the physical and logical topology of the network. It really is worth a read. So, but our auditors, one of the first questions we're going to ask is, look, you're a tiny part of my bigger problem, but you solve something for me. So if we entrust you all with our data, we have to know where that data lives. Well, Amazon doesn't give tours. They gave precisely one to their own auditor, Ernst Young, who wrote this giant report and then sort of a similar one for this SAE 16 certification, which replaces the old SAS 70 model, if you're familiar with that. It's basically infrastructure and data center kind of standards. So just a few details. They don't do blades. This came straight out of Hamilton's blog, and it's been confirmed by several of the engineers in their different data centers. These are fairly clunky, generic white box. Well, not truly white boxes, and you have no idea, but white boxes in might be Dell, might be HP, might be Silicon Graphics. Actually, for the largest time, until about a year and a half ago, 70% of their machines were SGI manufactured generic PCs. About 30 servers per rack, so it's not dense. I don't have a picture on this one, but they use these things now called Perdix, which are, they're god ugly. They sort of look like a giant trash can, not a trash can, but a trash, I don't know what you call it, but those things that are like outside buildings and restaurants where the trucks lift the whole thing, They're shipping containers that have been modified, uniform size shipping containers that they can put on the back of a truck and put anywhere. So that's made it even trickier. Umtala? There's 3 locations in Oregon. I can get more information if people are interested. But anyway, those were nearly completely Perdix from the beginning. In other words, it's like one of those portable storage buildings on wheels, and it's pre-wired, hooked it up, and we're ready to go. And the power consumption on these things, it's all over the board. They do have a couple facilities next to major waterfalls. So, but as I said, here, welcome to EC2 East. We've got it for each of their data centers, except in Tokyo. that's been much trickier, partly because we didn't have anyone that speaks Japanese and we were doing this research. But very, very beefy security. And, the biometrics, the hand cage, the 2-month whitelist sort of thing. This was kind of neat. I don't know if you guys have seen this. It's got Greg's cable map. This is the underworld. This is the sort of the international core, submarine cables that the top ISPs and global exchanges use. I thought I had a second one, but I didn't bring it with me. But there's a mashup of this with their data center location, so you can actually see, how far out they are. Anyway, it's kind of worth fooling around a little bit. If you're a network guy, and if you really care, you can spend a week on this stuff. And again, this information is all out there. The public and private peering, who has privileges, where the address is, who the contacts are. I would never, ever actually, I pity some spammer or something who would try to go and scrape the phone numbers for these guys, because that would be not good. But this is a complex link of every major ISP and global exchange in the world, and it ties in directly to their CDN, to their whole edge network. And this is just one site you guys are probably familiar with, but there's several others like this. And it's updated all the time. And a lot of times in forums, you'll see things like, I'm trying to get an API problem in my random dev thing figured out, and I'm getting an error because can't connect to, ATX Communication Inc., ASN number of blah. I mean, sometimes it throws up weird errors like that, and, that's kind of odd. This is one of the risk and compliance papers I was talking about. It actually is really good. I don't know if I mentioned it earlier, but in terms of their security side, in 2009, their CISO kind of gutted the FBI's cybercrime unit. You may be familiar with it because that was the one that was kind of punked by Anonymous a couple months ago, on that call. So I don't know, I heard they're still hiring, but Amazon took 2 or 3 of their best guys. I know we're kind of getting short on time, so I've got lots more detail, slides, pictures, but maybe we should sort of open it up, if that makes sense. As I said, this has been a project for about 1.5 years. Oh, by the way, the other thing I should say is the punchline to all this is, this isn't like it's an advertising or whatever, but one of the outcomes of this was our group was able to use the public infrastructure in a way that, in one of the first in the pharma industry. So in other words, we can right now bring infrastructure up that's fully validated, fully qualified, pre-qualified, self-documenting. And by that I mean, is NTP set correctly? How much lag is there? Do we have robust connections? You guys may have heard of the Chaos Monkey, Netflix Chaos Monkey. It's this idea that, if you say that you're resistant to random node failure, the best way to actually make that happen is to, programmatically kill nodes at random. But in other words, some percentage of your nodes in a large cluster kill, and every day see what happens. It's it's kind of gutsy and sort of separates the truth from the bluster. But anyway, the toughest auditor I've ever had spent probably a week on this model and basically came back and said, I can't find a problem with it. One of the things we do in our contracts, we have clients that say, after the study's up, you have to destroy data, you have to physically shred it, you have to ensure that things aren't available. So we have to worry about that. We have to worry about what if we're doing nothing wrong, but some guy who's co-located, or one server down, is busted for porn or gambling or something like that, and the feds come in and take the equipment. Well, in the U.S. under the privacy under the Patriot Act, your ISP is not even obligated to inform you, and so sometimes there's monitoring and things like this. So we've addressed that. So one of the ways that you do that is, you do strict encryption. You keep the keys off cloud, but yeah, at the end of the day, there's got to be a certain level of trust. there's been some hypervisor visibility, vulnerabilities rather. That big reboot in December of last year was an XML sort of a signature attack, an envelope signature attack problem. They've got great APIs, but they're built into everything they do. So when there's a fundamental security flaw like that, it can be painful to mediate. So anyway, we are up. I am obligated to no NDA, either to Amazon or my company, and happy to answer questions in a few minutes from me. Thanks.
Any questions on the floor?
So you're saying that you encrypt your data in Amazon Web Services, but it doesn't reside in memory on the machines, or I don't understand how you would do this. And then that's why I would never put anything in the cloud, because Patriot Act can always obtain the data.
I didn't hear the last part.
With the Patriot Act,
right,
the government can always access the data, so I would never put anything in the cloud.
Right. So in terms of accessing data, if we're talking about whole volume encryption, and it's done at boot time, and something like Lux, with AES encryption, is put on at boot time, for the database side of things, for the application side of things, for the scratchpad side of things, on reboot, that machine has to do a web services call out through a token, and if not, all we've got is scrambled junk. I mean, if anyone's listening, it's an SSL connection. So presuming you're not, at the risk of man-in-the-middle attacks, fine, take my drive, take the whole server. I've got the key, and it's, the whole volume's encrypted. The implementation for that is really hard. There's a company called Instratus that's, I've got a lot of respect for these guys. They've open sourced up a lot of their products, and I think they may have actually, I think it's on SourceForge actually, has this mechanism. But as Schneier was talking about, there is a level of trust. Do you trust that there's not, when statements are made to the federal government and the NSA and the FBI that say, we've technically disallowed the kind of monitoring that could sort of puncture through. Well, okay, but that's one risk. So what are other risks? If you buy that, then you still have to worry about co-tenancy. You have to worry about drives die. And on these things, I didn't get into this, but the whole EBS, the elastic block storage and instant storage, I don't know why, at this point, for serious applications, it's not clear at all to me why anyone would use EBS. All their architecture guidance says use it. I know that there's religious wars about this sort of thing, but if it's instance-based storage, and you pre-initialize the disk, this is brilliant too, by the way. Amazon doesn't pre-initialize the disk between users, and they've got they've got like in a golf cart, even if it can go faster, you put the pedal all the way down, but it's like limited, a governor, I think they call that. It's almost like a software governor on I/O. And so, but if you pre-initialize the disk, it's something like a 35-40% I/O improvement. So there's some things like that where, yeah, I wouldn't touch EBS because you're on a giant SAN. I would do local storage, and I do the traditional whole disk encryption. The check comes at boot time. If the key's not done, it doesn't come up. And if they're monitoring, then it means they modified, the underlying kernel. So build your own. I actually am a big fan of Amazon Linux, their version of it. Partly because it's binary compatible with CentOS, which is binary compatible with Red Hat, and that helps with some really annoying things like Oracle compatibility. But I also like it because it's GPL. One other thing I should mention. At the end of the conference, Amazon Web Services Linux has never been released outside. It's GPL, so what you do is you sign up with an account, you go online, and you can get a package at a time. And you have to go through this really annoying interactive script where you have to type and get the lines back. That's annoying on multiple levels because, anyway, we're announcing that Amazon Linux is full source code is going to be online tonight after the conference and on GitHub, and I hope that Hope it stays up. These are all GPL packages, so there's no, I don't think there's any license issues. And on the order of 3,500 or so YUM RPM packages. So we'll put some more updates out on Twitter as that goes. Okay.
Great, fantastic. Thank you very much, Kenneth. More questions? Feel free to approach him throughout the rest of the day at the conference venue.